Students, last class we studied about continuous charge distribution. In this video, we will study about Gauss theorem. This is the second law in this chapter after Coulomb's law. Okay, this is very important also. There are three applications for Gauss theorem also. Statement, it states that the total electric flux over a closed surface is 1 by epsilon 0 times the net charge enclosed by the surface. Okay, it states that total electric flux over a closed surface is 1 by epsilon 0 times the net charge enclosed by the surface. Okay. Consider a closed surface S having charge Q. Then by electric flux, we know that electric flux phi equal to integral E dot ds. Okay. Here this is a closed surface. So closed integral or surface integral E dot ds equal to 1 by epsilon 0 times the net charge enclosed. This is Q. Okay, net charge enclosed. Then Gauss theorem, phi equal to Q by epsilon 0, or electric flux surface integral E dot ds equal to Q by epsilon 0. This is the equation. Proof of Gauss theorem. Consider a charge Q placed at a point, okay, and construct a Gaussian spherical surface of radius. We can take radius as small letter r. Okay, we are placing a charge here and we are constructing a Gaussian surface in this electric field. Okay. Consider a charge Q placed at a point. We can take this point as O in free space. Consider a charge Q placed at a point O in free space. A Gaussian surface, a Gaussian spherical surface S of radius R is constructed with O as its center. Let P be a point at this surface. Okay. Let P be a point at the center of an elementary surface area ds. Okay. Take this small area as ds. Okay, the electric field direction in this point, electric field direction is this direction, is in this direction. Okay, also this area element, that direction also in same direction, that is electric field and ds are in same direction. Okay. Then electric field intensity at P is, we know that electric field intensity E equal to 1 by 4 pi epsilon 0 Q by R square. Take this as equation number 1. Next, the flux through ds is, we know that flux d phi equal to E dot ds. or this is equal to E ds cos theta. Here theta equal to 0 because ds and E are in same direction. Okay, are same direction. Then d phi equal to E ds. Okay, then total flux equal to phi equal to integral E dot ds or surface integral E dot ds. Okay, take this as equation number 2. Substitute equation 1 into, then we get phi equal to integral surface integral. For instead of E we substitute 1 by 4 pi epsilon 0 q by r square. Okay, into ds. Then phi equal to q by 4 pi epsilon 0 r square integral ds. Okay, this ds means small elemental area. This is a sphere, so total area equal to 4 pi r square. Okay, 4 pi r square. Substituting we get phi equal to q by 4 pi epsilon 0 r square into 4 pi r square. Then cancelling these terms we get phi equal to q by epsilon 0. Hence Gauss theorem is proved. Next, some important points regarding Gauss law. Gauss theorem is true for any closed surface irrespective of size and shape. This is very important. Okay. Second one is the term Q includes the sum of all charges enclosed by the surface located anywhere inside the surface. Okay, this charge only inside the surface. Okay. Third point, the surface that we choose for the application of Gauss law is called Gaussian surface. Next point, in the situation when the surface is so chosen that there are some charges inside and outside. If there are charges inside and outside, we only consider inside charge. Okay, Gauss theorem however represents only the total charges inside. Okay, first point, Gauss theorem is true for any closed surface. There is no particular shape or size. Okay, the charge q means total charge inside the surface. Okay, the surface we chosen for Gaussian law is called Gaussian surface. Okay, if there are charges inside and outside, we only consider Gaussian law total charge inside the surface, Gaussian surface. Okay, next two important points are Gauss law is often useful towards a much easier calculation of electrostatic field when the system has some symmetry. If a system has some symmetry, Gaussian law is very useful for calculation. Okay, next law, Gauss's law is based on the inverse square law. We know that phi equal to q by epsilon 0 is the equation. This is derived from electric field intensity. Okay, then Gauss law is based on inverse square law, depends on distance contained in the Coulomb's law. Okay, any violation of Gauss law will indicate departure from the inverse square law. Okay, these are the important points regarding the Gauss law. Next class we will discuss the applications of Gauss law.